Good morning to all. Okay. So yesterday we have seen Debye-Huckel-Armstrong equation. Okay. Inter-ionic attraction theory and electrophoretic theory. Okay. So in that actually an ionic atmosphere is created, right? So here positive ions are surrounded by negative means anions. Next here there is a disturbance between this. If you pass the EMF, what will be happen here? There is a disturbance. That environment get disrupted and pass means cations move to the anode and anions move to the cathode. So not only that in electrophoretic theory, so what we have known by this. Electrophoretic theory co-effect. So here along with solvent molecules, these ions are moved to that opposite electrodes. Okay, so that is the main difference between this interionic attraction theory and electrophoretic theory. Okay. So this is the equation. Okay. So now we can equate these forces acting. Next one. Next equation. So what will be happen here? Forcing acting on the ion ith type. Means here we are using the ith type. Whatever the ion means, if it is a cation is surrounded by anions. So next another case is also obtained. That is nothing but anion is surrounded by cations. Okay, so here the ith ion, whatever it may be, cation or anion. Okay, this ith ion as it moves through the solution with a steady velocity u f state. Okay, u I state. So let's see this. How the force is acting on this electroforce. Okay, electrophoretic force also act as a retarding force. Here electrophoretic force act as a retarding force. Okay, so thus we have epsilon z I v is equal to, we know that, right? So next ki ui plus epsilon z I k by 6 pi eta, okay, into k I v. So we are expressing other term, okay, which is that this one and relaxation force. We have to add the both effects. Okay, we have to add the both effects. These are nothing but ionic attraction theory and electrophoretic theory. So this is the electrophoretic theory, and from ion attraction theory, what we have here, epsilon cube z I k by 6 dkT. 6 dkT omega d. This is equation 5. This is equation 5. Wrote down this and go for next one. Okay, so we have to rearrange this equation by dividing this ki b. Okay, we have to send this term in this side. Okay, so what we'll get? First, here by dividing equation 5 5 by KI B. Okay, we have to divide this equation by KIB. Okay, so we have to divide this equation by KIB. So then we have to arrange this equation into, okay, and rearranging we get UIB, because here we have to send in this, no. Okay, is equal to epsilon Z I by K I. Okay, so we have this one, and next we have to divide the KIB, right? Okay, so next minus epsilon Z I K by 6 pi eta, okay, into K capital I V, plus what we have here, epsilon cube Zi K by 6 dkt, okay, dkt omega V, omega V. L minus, here we will get the minus, because we have to send this term into this side, so that's why we get the minus epsilon Zi K by 6 dkt omega V. Okay, omega by Ki. Here we have to divide by Ki, right? So here Ki getting cancelled, and we'll get the only Ki. This is equation 6. Actually, we have to take this Ki, Ui will be there, is equal to, if we send this term in this side, what we have here, epsilon Zi V will be there, right? Next, we have to send this term into this side, what will get, minus epsilon six pi eta into Ki V plus minus, because we have to send this term into this side, right? So next minus Ki V, what will have, epsilon cube Z I K by 6 dkt into, we have omega, right? If you divide by KIV, what you will get here, KIV, okay. So next we have to write KIV, next we have to divide the KIV. So what will be happen, this is extra step how we will get from this equation to this equation, okay. Here Ki getting cancelled. Okay, V getting cancelled. So thereby we'll get this one. Okay. Next Ki getting cancelled. So thereby we got this one. Okay. So next what will be happen here? Here V getting cancelled. Thereby we got this one. Okay. I hope you understand. Okay, ma. So actually we have this equation. We have to combine both electrophotic effect and this ionic attraction theory. Okay. So we means here two effects will be there. So that's why we got this one. So when you divide this equation by KIV means so if this first you have to write first this one, next second, third because I have I written directly, but for your understanding, I have written this equation extra. Okay. First ఇది రాయండమ్మా తర్వాత followed by this one and next this one. Okay. ఇది ఎలా వచ్చిందని చెప్పడానికి మీకు ఇది చెప్పాను ఈ ఎక్స్ట్రా స్టెప్ వేసాను. ఓకే. Okay, ma. So next. So we have to take the potential gradient. 1 volt is equal to 1. So then what we'll get? Okay. If we take potential, okay. So potential gradient as 1 volt per centimeter as 1 volt per centimeter. We have to take V is equal to 1 by 300 value. Okay. V is equal to means that is nothing but we have to apply wherever we have V, we have to apply the 1 by 300. Okay. So actually we have V in denominator. So what we will get here? Okay, we have to write this UI. We have to send this term into that side. Okay. So then what we'll get here? E UI is equal to epsilon Zi by 300 Ki, okay, minus epsilon K by 300 into Zi 6 pi eta plus epsilon cube Zi K by 6 d Kt, okay, omega by Ki. So we have to apply this. If you send this term into this side, what will get? So here we have to write KIV. Here there is no V, but we have to send this term. Okay, 1 by 300 value, right? So 1 by 300 means what here? This is in denominator, right? So that's why we can send this term into that side. This is equation 7. At infinite dilution, K becomes 0. At infinite dilution, K becomes 0. K becomes 0. So then what will happen? Wherever you have this, you will get the 0 values. Okay. In case K7, so you have to write Ui naught is equal to epsilon Zi by 300 Ki. Okay, means here K is there and K is there. So this term all becomes 0. Okay, so because we have here K also here, so this term totally becomes 0, and we got only epsilon Zi by 300 Ki. If because at infinite dilution K becomes 0. Okay, if K is equal to 0, this term gets 0. Okay, so we got only this bar. Okay, so this is equation 8. But we know that lambda I is equal to I star. So that lambda I is equal to Fui naught. Okay, so Ui naught it becomes, so Ui naught is equal to lambda I by F. So we have to substitute this term in the place of Ui. Okay, we know that here lambda I is equal to F Ui naught. So we have to get the term Ui. So that's why we have to send this F into this side. Okay, so then we got this lambda I by F. So what is the value here? Lambda I by F. So we have to substitute this value into the equation 8. Okay, equation 8. This is ninth equation. So next one. So we will get this as a, so what we have, E Zi by 300 Ki. So what is the Ui value? Ui value is lambda I F. Okay, this is equation 10. Again we have to write U is equal to lambda by alpha F. Okay, So substituting this equation means we have to write the F value. Okay. Substituting equation 10 and 11, 10 and 11 in equation 7. Okay, we have to substitute this value into this one. Okay, equation 7. Then what we get, wherever you have ui, we have to substitute the value, this one. Okay, so we have to substitute in this equation. What is the value? Lambda alpha f. Okay, we get here lambda I by alpha f is equal to lambda I naught by f minus e a by 300 into z I by 6 pi n plus epsilon by 6 d kt, okay, into e z I by your k I into omega. This is equation 12. If alpha is equal to 1 means, in case this is said to be completely ionized. If complete the solution with the electrolyte completely ionized, then alpha is equal to alpha becomes 1, completely ionized. So the above equation, what will be happen? Alpha is equal to 1 at 1 Faraday. So that we have value is F also will be 1. Okay. F and alpha becomes 1. So thereby we'll get only lambda I, because this value becomes 1, right? So then we got lambda I is equal to what we have here, F is also becomes 1. So thereby we got lambda I naught minus epsilon k by 300 zi by 6 pi eta plus epsilon by 6 dkt into epsilon zi omega by ki. This is equation 13. This is somewhat a very big topic. Okay, ఎక్కువ డెరివేషన్ ఉంటుందమ్మా దీనికి. కాన్సాగర్ ఈక్వేషన్ ఇదొకటి కొద్దిగా టఫ్ ఉంటుంది. We know that epsilon zi ki is equal to 300 lambda I by f. We have to substitute the value. We know that epsilon zi by ki is equal to 300 lambda I by naught by f. So we have to substitute wherever this value we have to substitute this value. Okay. Means here we have this value. If you write this term in this here, what we have here is epsilon zi ki. Okay. So we have to substitute this term 300 lambda naught I by f. So we have to apply the values, what is 6 and what is the pi value. We have to apply all the pi is nothing but we get the 0.314 and 6 pi n. So we have to simplify this equation by substituting the values what we have. Okay. So the equation becomes, so the equation 13 becomes lambda I is equal to lambda I naught 29.15 Zi, okay, by dt or n theta plus 9.90 into 10 power 4 by dt by t by 2 and lambda I naught into omega. Here I have no space here, that's why I am writing here. Continuation in the so root of, we have to write the concentration as well as ions. Okay, charges. C minus Z plus square plus C minus ions minus Z square. Okay, but here this is equation 14. ఇది కొంచెం టఫ్గానే ఉంటుంది, మీరు బాగా ప్రాక్టీస్ చేసుకోవాలి. Actually, what is C? Ca is equal to Ci Zi. So, equation 14 becomes lambda I is equal to lambda I naught minus, okay, 29.15 Zi dt power of theta plus 9.90 into 10 power 4 dt t by 2 lambda I omega into, so we have to substitute the value. C, we have Ci here, this is C minus Z plus square, C minus Z square, Z minus square means charges of cations and anions. Okay, we have to do the squares. Okay, so instead of this we have to simply substitute this as root of C Z plus and Z minus. Okay, Z plus plus Z minus. Okay, this is equation 15. Okay, no? So actually we have this one, but finally we got lambda is equal to lambda I naught minus 29 point. Finally, so we have z plus is equal to z minus becomes 1, and here omega value becomes is equal to 2 minus root 2 root 2. So we have to substitute all the equation, then here the values changes. Okay. So what we 8 we got 82.4. Okay, 82.4 by dt half n, okay, plus 8.20 into 10 power 5 by dt 3 by 2, okay, lambda I naught into, we have to just write this term is a concentration root C, okay, root C. So it also can be written as totally lambda is equal to lambda naught. We have to simplify this equation, okay, as a plus b. Okay, we have to write it as a. Okay, next what we have here, b, this term b, lambda naught into root c. Okay, this is 17th equation. Here a and b are constant, which depend on the nature of the solvent. Here a and b are the constant and which depend on the nature of the constant. Okay, a, what is the a here? 82.4 by dt. Dt power half beta is equal to a value. What is b value? 8.20 into 10 power 5 by dt whole power 3 by 2 is a value. Okay. So this is the final Ansager equation. Okay, Ansager equation. By this we have completed almost, okay, only maybe almost all topics covered. Okay, I will tell you 8th equation. What is 8th equation? Wait. We have that value, okay, ui is equal to, we can write that value, okay, means if k becomes 0 na, k becomes 0 na, that value all becomes 0, okay. If you apply the k is equal to 0, k into 0 is anything is 0, right? Okay, Samrin. Okay, if you substitute k is equal to 0, so if it is multiplied with any value, because k is equal to 0 now, so that term totally will become 0. So thereby you will get only that u e epsilon zt by 300 ki. Okay. Before 7th equation we have I'll write for you once again. First note down this. I'll write. Otherwise take screenshot and explain. Okay. Okay, got it? Because k is equal to 0 now. So if you apply k in that, k only k, not ki. Okay, you have to write the value k is equal to 0. Then if you multiply 0 with any number, it becomes 0. So that's why that total term, the value, it will get that 0. Okay, and we got only the epsilon zi by 300 ki. Okay. Is it clear? Okay, I'll continue later, ma. Okay, ma. Almost we have completed this one. We have completed totally electrochemistry. Okay, I'll send you material. Don't worry. Thank you.